Determine the left-sided limit and the right-sided limit, and the two-sided limit as x goes to 6 of the absolute value of 6 minus x over x squared minus 36. Each of these limits involves the limit as x goes to 6 of the absolute value of 6 minus x over x squared minus 36. The first thing to do is try plugging a 6 in for each of the x's. That'll give us the absolute value of 6 minus 6 over 6 squared minus 36. So we have the absolute value of 6 minus 6 over 6 squared, which is 36, minus 36. 6 minus 6 is 0. 36 minus 36 is 0, so we have the absolute value of 0 over 0. Since the limit resulted in a 0 within an absolute value, it is required to work out the limit from each side separately. So we can look at the limit as x approaches 6 from the left side, indicated by the negative superscript on the 6, and limit as x approaches 6 from the right side, indicated by the positive superscript on the 6 of that same expression. Absolute value of 6 minus x over x squared minus 36. And that'll be on both of them. Let's start with the left side limit. The left side of 6 on the number line, or less positive than 6, but close to 6. For example, like 5.99. If we plug something less positive than 6 in for x in the absolute value, like 5.99, subtract it from 6, you'll end up with a positive number in the absolute value. Since we have a positive number in the absolute value will ensure that it stays positive by not changing it at all. So we can remove the absolute value symbols, replace it with parentheses, and have a positive outside of it, so we do not change it at all. At this point, we have the 0 over 0 indeterminate form, and we will continue to have that until we can factor and cancel. Now in the numerator, I'm going to factor a negative out of it so that I have the x become a positive and the 6 become a negative. In that way, it'll match after factoring the denominator, because we have a difference of squares, which will factor to an x plus 6 and an x minus 6. And we can now see the factors that are making the 0 over 0 indeterminate form. It's the x minus 6, which can cancel, leaving a negative 1 in the numerator. So we have the limit as x goes to 6 from the left side of negative 1 over x plus 6. We no longer have the 0 over 0 indeterminate form, so we can try plugging a 6 in for the remaining x's, and we have negative 1 over 6 plus 6, or negative 1 over 12. Now we can work out the right side limit, and we are to the right side of 6 on the number line, or more positive than 6, say like 6.01. If we look at what will happen in the absolute value 6 minus x, where x is something more positive than 6, like 6.01, 6 minus that will be a negative number. Now the absolute value will ensure that what comes out of there is a positive number. If what goes in is a negative, the absolute value will take the negative of it. So we can remove the absolute value symbols, replace it with parentheses if we have a negative out in front of it, to cancel out the negative number and make it positive number. We have the 0 over 0 indeterminate form, so we will once again want to factor and cancel. In the numerator, I'm going to factor a negative out of that 6 minus x. That will make it become positive, and switch the signs on the x and the 6 in there, just so it's ready to cancel, because the denominator factors is a difference of squares, x plus 6 and x minus 6. The x minus 6's can cancel each other out, leaving a positive 1 in the numerator. So we have limit as x approaches 6 from the right side of a positive 1 over x plus 6. And we can now try plugging the 6 in for the remaining x's, since we'll no longer have the 0 over 0 indeterminate form. We end up with 1 over 6 plus 6, or 1 over 12. For the two-sided limit, we can compare the results of the one-sided limits. They're right here. Since they are not the same, the two-sided limit will be does not exist. And there's the results of the three different limits.